All right, folks, it's Bass Action, back in action here. In this video, we are going to go through how to write equations for tangent and cotangent based on a graph. So the first thing that I want you to recognize on a tangent and a cotangent graph is that one of them will always need to have a reflection. This is different than the sine, cosine, secant, and cosecant that we had. On tangent and cotangent, one of them will always be a reflection. So you really need to have it in your mind what the various graphs, what the two graphs, their parent functions look like. So a parent tangent graph starts at the bottom and goes up to the right, and a parent cotangent graph starts up on the left and goes down to the right. So when we look at this graph here, we can see that this is starting down on the left, is going to go up on the right. So this is in the shape and in the direction and behavior of a tangent parent graph. So this one will not have a reflection for tangent, but it will have a reflection for cotangent. One of these has to be a yes and one of these has to be a no. So when we start building our equations, both the y equals, we know that the tangent will not have a negative in front, but the cotangent will have a negative in the front. Now, the next thing that we want to look at is if there is a shift, okay? So if there is a vertical shift. Now, when I look at this, I can see that these middle points, these center points are right here on this x-axis. If these points were shifted up or down, there would be a vertical shift. But since they're right here on the x-axis, we can see that there is no vertical shift. So this is going to be a none, so we won't need to add or subtract anything on the back end or the front end, wherever we want to put it. We can also then grab these points. These will usually be there and be kind of clear for you to read. They will be halfway between the middle, so they're that fourth, okay? So halfway between the middle point and one of the asymptotes, okay? And I can see that these are going all the way up to 3. So this graph has a vertical stretch of 3. So on the tangent, I'm going to put just a 3, keeping it a positive. On the cotangent, I'm going to have the negative. Then I can go ahead and write tangent. I'm going to go ahead and write cotangent. I'm going to set these up also with my nice parentheses. So it's all ready to leave it in the nice factored form. I think the phase shifts are actually pretty easy to grab on these, okay? So on the phase shifts, what we can do is, again, think about the parent graphs. A parent tangent graph would cross right at 0, 0. So you can easily find the phase shift for tangent by just using any of these nice points right here, because instead of at 0, 0, it's been shifted over to right here. So we're going to use this point for tangent. Now, to find that point, again, this one hasn't been labeled. We saw this in a similar way on one of our other videos, that it's going to be halfway between my 0 and my pi over 18. So its phase shift is going to be pi over 36. Half of that pi over 18. So it's going to be pi over 36. So I can fill that in as a pi over 36. For cotangent, I'm thinking again about its parent graph. Cotangent's parent graph has a nice asymptote right on the y-axis. So to find the phase shift for cotangent, all I have to do is grab any one of the asymptotes, and that will tell me that phase shift. So I could do a phase shift of a negative pi over 18, or I could shift to the right pi over 9, or I could even shift to the right 5 pi over 18. I'm going to go ahead and choose to do the pi over 9. So I'm going to write that in as a minus pi over 9. Now, the last thing that I need to do on this tangent and cotangent is I need to figure out what my period change is. And in order to figure out the period change, which is going to get us to the omega, we're going to just look at the distance between these asymptotes. Now, you might be able to do it in your head, but right now my denominators aren't the same. So I'm going to flip this pi over 9 here. I'm going to flip that to a 2 pi over 18. It's going to make it a little bit easier for me to do that mental math. So from a negative pi over 18 to a positive 2 pi over 18, that's going to be a distance of 3 pi over 18, which is going to reduce to a pi over 6. So this period is pi over 6. Now remember, on tangent and cotangent, we got that period by doing pi divided by the omega. Not 2 pi, we did pi. So again, just like before, if you need, you can cross multiply to find this, but either way, you should be able to get to an omega value of 6. That means that we can come down here to our equation and we can drop in the 6, and there we go, our equations are done.